So, so economics often evaluates situation. So let's take a very simple example. You want to build a road. You want to build a road that connects two cities. The question is, should you do it or should you not do it? How do you know it's a good thing to do, right? Now, people often use cost-benefit analysis, but cost-benefit analysis is a bit of a convoluted version of Pareto criteria. And it is so convoluted and it has got so corrupted that it's useful to question cost-benefit analysis. So I will talk about the relationship between cost-benefit analysis, but the primitive that you always use is this idea that Pareto came up with. So let's talk about what Pareto said. So you have a situation A, a society is in situation A, and if you have a policy intervention, any policy intervention, it could be a tax policy, it could be constructing a road, it could be designing a new policy, it could be tax credit, any situation. If you have an intervention, policy PB, it would lead to a situation B. So what you want to do is you want to compare to situation A with situation B. And you want to ask yourself, is situation B better than situation A? Right? Now, the question is, how will you compare? Any intervention would create winners and losers, right? So if it creates winners and it creates losers, the question is, can you objectively compare? You could subjectively compare. So if I think I have a policy which is going to take money from the rich, tax the rich, and provide food stamps and other things to the poor, I would consider that a good policy, moral policy. But the question is, can we use an objective criteria or are we using a subjective criteria? So the moment I said moral, I was using a subjective criteria because I was making a value judgment that at the margin, if I extract taxes out of the rich and give it to the poor, it wouldn't make much of a difference to the rich, but it would make a huge difference to the poor. But I'm using a subjective judgment. And the issue with subjective judgment is that if two people decide to bargain something, they can decide what they want to do. But should a third person use their subjective judgment to determine their fates? So it starts becoming really complicated in terms of somebody externally using subjective judgment, because subjective judgments can be extremely vague. So Pareto, almost 150 years ago, came up with this idea of a Pareto criteria. And he said the following. He said, any intervention that makes some people better off without making anybody worse off is a Pareto improvement. What that basically means is that if you have a situation where you create winners but no losers, that is a Pareto improvement. If you have a situation when you're creating winners and losers, you have a situation where if you use a policy to go from 1 to A, you create winners and losers, then you're redistributing, taking from one person and giving to another person. So you're redistributing, and that is a situation where you are on the efficiency frontier. Now, this might assault your senses because we all use the word efficiency in a very colloquial way, right? So is this efficient? Yes. Have you made it more efficient? Yes. Why have you made it more efficient? Well, it's better. If you had to pin down an objective definition for efficiency, I mean, at least, when I ask people, they struggle to find an objective definition for efficiency. And the only definition of efficiency at least economists are aware of, or at least I am aware of, is the Pareto definition of efficiency. It's a very flawed definition. And the reason it's flawed is because there are lots of situations where you create winners and losers. And what it says is, if you are in a situation where you're creating winners and losers, then you are on the efficiency frontier. But if you can create winners but no losers, then that means you're inside the efficiency frontier, and that means you can use a policy to get to an efficiency frontier. So let's operationalize this definition. So let's say me and you are sitting across a table, and I have a sandwich, and you've not brought anything for lunch. Now, what this is saying is that if there are winners and losers, as in the sandwich gets redistributed, then you're on the Pareto efficiency frontier, which means whether I have the whole sandwich by myself, or I give you the whole sandwich, or we share the whole sandwich, all those actions are on the efficiency frontier. But if while giving you the sandwich, I drop the sandwich, I waste some, that means we could have created winners by not wasting. We could have created winners without having any losers. So the part of the sandwich that got wasted would not have got wasted, and that would have created, you would have got more of it. I would have got half of it, but if some of it fell, you would have got more of it. So there are no losers. And so identifying Pareto improvements means that you can get to the efficiency frontier. But once you're at the efficiency frontier, then you're distributing things from one to another. Now, this in the context of development starts becoming extremely important, because a lot of development problems are about Pareto improvement. A lot of problems in the developed world are about redistribution. So developed world, the kind of economies don't have scope for Pareto improvement. But in development, and we'll talk specifically about examples where you can illustrate that. In development, there is a relatively large scope for Pareto improvement. So you don't have to make subjective judgments in trying to find policies which improve the lot of a country. Okay. This is not if you have come across Pareto improvement and Pareto efficiency, the criteria for the first time, it's not something that's easily absorbed. It takes a little while to absorb it. Now, development economics, to a large extent, the role of development economics is to find interventions that increase the size of the pie so that everyone gets a bigger slice of the pie than they were getting before the intervention. And the slice of the pie here is a reference to the aggregate output or the aggregate income in the society. If you start increasing the aggregate output or aggregate income in the society at such a rate that everyone's better off, which is what happens when countries start growing exponentially. I mean, if you look at India and China, they've been growing exponentially, and the rate at which they're growing exponentially, that means to a large extent, you can create winners without creating losers. Having said that, it could still contain situations where you're creating losers within it, and that starts becoming problematic. And that's where kind of the idealistic version of Pareto efficiency meets the reality, and that's where policymaking starts getting more difficult. But to a large extent, a lot of developing countries have scope for Pareto improvement. And I'll specifically talk about, I'll show you some really interesting evidence and hope to convince you about this. Now, before I move further, let me just talk about what does cost-benefit analysis have to do with Pareto efficiency. So cost-benefit analysis basically says that you can compare costs with benefits. And if the benefits are greater than the costs, then you should do that project. Almost all infrastructure projects are evaluated using cost-benefit analysis. Now, let's think through of the assumptions that are inherent in the cost benefit analysis. So if you're going to construct a road next to my house, I am going to be disturbed. The noise pollution will go up. The tire dust will go up. So, we're increasingly realizing that when you have a highway next to your house, that the tire, when it hits the asphalt, the road, the rubber breaks down. It creates really tiny particles, and they are PM25 particles, and they're absolutely debilitating for your body. I mean, they've been linked to the diabetes, they've been linked to vascular problem. So the local pollution out of a highway is terrible, the noise is terrible. Now, if somebody had to do a cost benefit analysis, what they would do is they would look at me and say, oh, the noise is going to bother you, that's a cost. But how do you aggregate the cost that I am bearing, the cost of making the road, the cost other people are bearing? How do you aggregate them? How do you add up all the cost? Now, if the costs have pound signs next to it, that becomes easier. Everything that has a pound sign next to it becomes easier. If the benefit also has a pound sign next to it, it becomes easier. But the question is, how do you put the pound sign when it doesn't have a natural pound sign? The discomfort that I feel out of having a highway next to me, it doesn't have a natural pound sign next to it. It doesn't have a valuation. So then what you do is you start saying, is there a market for it? And if a market exists, I can price it out. But there is no market for my noise pollution. So what do? Basically, people start attributing arbitrary numbers. So in the UK, one of the things people do is they will call somebody up and say, how much would you pay to reduce noise by this amount, this decibel? Or, when it comes to environment, they would say, how much would you pay to access this forest? And the value they're ready to pay, these are people who, are, in the middle of a Sunday afternoon, they're asked how much would they pay to access a forest, which is next to their house. They give a number that becomes their valuation. The benefit or the cost gets turned into kind of pecuniary monetary value. It gets added up, and there's a lot of scope of making assumptions about how you add up things, and that's how you get cost benefit analysis. Now, cost benefit analysis, what it's basically doing is saying you can basically attribute value to all the costs and all the benefits. What Pareto is saying, don't make a subjective judgment or worry about the subjective judgment. Try first for the objective part. Okay, so I don't know if this is interesting or not, but at least to me, it is really interesting because I always wonder whether the cost benefit analysis has been done properly or not. Now let's think of something very specific. One concept that I'll use again and again in the lecture when you start talking about growth is this idea that aggregate output and aggregate income in the economy is identical. So if you took the total output of UK, all the cars, all the oranges, oranges are not produced, but all the beer, everything that's produced in UK, if you added up all the output and added up everyone's income in UK, the two would be identical. Now, if you've done some economics, you should have done this. It's national income accounting. But if you haven't, it can be a little counterintuitive. And the simple idea behind this is that think of any firm. When they sell an output, the proceeds they gets divided up in the firm, right? So whatever the turnover of the firm is, it all gets divided up. So some of it goes in terms of taking care of the machines that are falling apart. Some of it goes into investment. The rest of it all becomes income, right? So any value added that the firm produces, right, which is turnover minus the kind of investment and the depreciation, any value added becomes somebody's income. So if you add all the value added across the economy, which is, and that'll become the aggregate output, it'll also be the aggregate income. Because every time something is sold, that becomes somebody's income. Now, the reason this is important is because it's easier to measure the output than to measure the income. So whenever we kind of will look at things, we'll often look at the GDP, which is often measuring the output. And we will use GDP for two things. We will divide the GDP with total population. So when you take GDP and you divide it by total population, that gives you, that would give you the average income. So when you take GDP and divide it by total population, it gives you the average income of the society, and it gives you an idea of the living standards of the society, right? There are ifs and buts because, the average, could hide within it inequality in the society. But, that's a second level of complication, okay? And we can deal with that complication, but we get a lot out of it by just looking at the GDP per capita, the average income of the society. We get a lot of information about what the average living standard in the society is. The second thing we do is we divide the GDP by total number of workers. Now, it should be fairly obvious that the total population and the total number of workers are not identical. Total population is greater than total number of workers because total population is all the whole population, the working population and the dependent population. So dependent population could be people who are younger than 18, or the people who are not working, or older people who are retired, or other people who for some reason cannot work. So the total population is always greater. The number of workers is lower. Now, usually there are not radical changes over time in the proportion of people who work, but sometimes there are, right? So sometimes there are. So there are two similar measures, but they tell you two different things. The first measure, GDP per capita, tells you about the living standards. And the second measure tells you about the productivity of the worker in the economy. Now, the two can go in different directions. If you have a growing population which is skewed towards children, right? So there are lots and lots of young children, then you'll have, the average productivity of the economy might be high, but the GDP per capita would be much, much lower. Now, there are two different things, because workers' productivity is, how productive they are. GDP per capita is the living standards. How much money does the average family have to buy food and buy the other essential goods, right? So when you have high population growth, sometimes this distinction could be important. Okay, so now let me tell you something which at least I find really interesting. Okay, this is a graph. What it does is it maps out life expectancy versus GDP per capita. So basically, on the horizontal axis, you have GDP per capita, which is measuring living standards. So living standards. On the on the vertical axis, you have life expectancy. So what is life expectancy? It's basically how much would you expect an average person to live in that society, right? Now, I'm going to tell you about a paper in a couple of slides where it would become evident that life expectancy is more important, is more important in representing what's going on in the society than just itself. It's not just about life expectancy. It can often be a very, very good indicator of what the quality of living standards is in that society. But for now, let's just look at life expectancy. Now, what this graph does is it looks at the relationship in 1952, 1972, 1992, 2007. Let me just move to the next slide because it's on the next one is slightly bigger version of this. So what you have here is not just what the relationship is. So this is the relationship in 1952. Now this graph is telling you a lot, giving you a lot of information. So every dot on this graph, every dot in this graph is a country. And what I've done is I have marked out some countries, kind of representative countries, so that we can track what happened to them over the kind of 4 or 5 decades. Now, the shape of the graph, the best fit for the graph, has a bit of an odd shape. Does anybody want to guess why it has this shape? So the shape is the GDP per capita, when increases by a small amount. If you start off from a low GDP per capita and you start from a small amount, the life expectancy gains are phenomenal. But as the GDP per capita gets into a higher territory, the gains become almost impossible to find, right? So in this territory, in this area here, very small changes in GDP per capita leads to very high, kind of high increases in life expectancy. But in this area, your GDP per capita can go up by huge amounts. It doesn't dramatically change your life expectancy. Any guesses why?
It's about the diminishing return approaching the end of the curve.
Yes. So one is that on the end of the curve, there is a limit. I mean, we still haven't found a way of, kind of extending life. So basically what you're getting to is a potential life, which is 80 or 90 years. And, you can get richer and richer and richer. It really doesn't matter because after some time you cannot extend your life. But why do you think it's increasing so fast at the lower end? Right? You could still have a diminishing returns, but an alternate shape of this graph could be this, right? Why such high returns early on? Question. Yeah, sorry. Go on.
Well, I suppose it's because at the lower end, there are relatively cheap measures that will increase life expectancy. So the example 52, 72, 92, those sort of 20-year jumps are vaccination programs. So vaccinations for some diseases are relatively cheap, and the gains made by developed nations, they can be benefited from by developing nations. So I think of a polio vaccine, for example, was probably developed, well, it was developed in what we now call the Western world, and it can be rolled out into developing countries relatively cheaply, which increases life expectancy disproportionate to GDP growth.
So True, but the question is, why is there a relationship with GDP growth? So the vaccination programs, somebody's got their audio on and they're in a very noisy environment. Can you please? Yeah. So somebody's got their audio on. Can you please shut down mute yourself? Okay. Yeah. So the thing about vaccination programs is that you can vaccinate people irrespective of their per capita income, right? I mean, it's, the question is, why is it related to per capita income?
Oh, I think, so why is it specifically to per capita income? Then I suppose there's an argument of an increase in GDP would suggest that you'd also have an increase in basic services. You could maybe have an increase in healthcare provision, an increase in potentially in road safety. All of the things that might cause earlier death could be prevented with relatively modest increases in GDP.
Absolutely. So the point I was trying to get to is that there is something about government capacity and institution that changes, because the idea is always there. And I don't know if you're getting to the sense of Pareto optimality here, which is these ideas are there, which can create winners without creating any losers. What stops? So look at Ethiopia. I think Ethiopia is very fascinating because it's a poor country. It hasn't progressed that much, but it still has a kind of a group of people who have capacity to run the society. So it's not that they can't run their vaccination program, but it's not seen an increase in life expectancy at all. What's fascinating to look at is what happens to China or what happens to Brazil, which is small changes, very, very small changes in per capita income has been accompanied by very large changes in life expectancy. And I'm not reading causality, by the way, into it, because it could be that something independent's happening, which is driving up changes in per capita income as well as life expectancy. All we are looking at is correlation here, but it is quite phenomenal to see how much China between 1952 and 1972 has jumped, or how much Brazil has jumped, right? So now I'm going to leave this here, but I'm going to pick this back next week and the week after, which is this idea that there is something about public goods which are difficult to arrange, which are related to why countries find themselves trapped. It's something about public services, and public services are kind of a generic term, but we're going to define public goods and find the relationship between public goods and GDP per capita. And that relationship and public goods, GDP per capita, and I hope you can see where infrastructure comes in, because public goods infrastructure is a class of public goods. So public goods are critical for development. Infrastructure in the same way is critical for development. What we are picking up here is public goods associated with healthcare. And what this course is going to be about how infrastructure is critical. So the example that I really like, I mean, when this paper came out, it was the first time it kind of struck, when I read that paper, the first time it struck me that, the world of development is far more complicated. It's 20 years ago, I was a PhD student. So what Esther Duflo and Banerjee, Abhijit Banerjee, and if you follow development, you may know that they won a Nobel Prize a year ago for development economics. In one of the early papers, what they did was they looked at, in Rajasthan, what measures reduce the absence in public services, absence of doctors and doctors and teachers in schools and hospitals. So what they were basically looking at is under what conditions are publicly employed school teachers and doctors more likely to turn up for work in rural areas in India. And they did this in India and Rajasthan, and then they've replicated the study at various other places. And they found one of the best predictors of where teachers and doctors are likely to turn up is proximity to road. So if the school or hospital is next to a proper road, you're more likely to have the school teacher or a doctor turn up. And that just means that if you don't have the infrastructure, you can't deliver the healthcare, because you can hire doctors and teachers, whether they turn up in rural areas or not, you have no way to check, right? So, I mean, I'm going to come back to this. I'm going to kind of giving you a preview, and maybe, maybe too much of a preview, because I don't want to confuse you. But this is where we are going. Now, let's look at data on life expectancy. So if you're interested, I have the database for all the countries from 1952 to 2007. It's a Gapminder database, or you can find it on the World Bank database. But let's look at some specific countries and see what's happening. Now, this is a style of graph that I'll use again and again. So I'm going to explain it very carefully because we're looking at it for the first time. In this graph, the bottom line here, has been done according to United States, the reference country. And what this allows you to do is look at the life expectancy, let's say in Singapore. So the life expectancy in Singapore has followed this path. And you can immediately look at this graph and say, in 1952, Singapore started with a life expectancy, which was much lower than United States. And compared to United States in 1952, so United States life expectancy in 1952 was 68.4 years. Compared to that, where is Singapore, right? It just allows you to compare. And this graph will tell you a very simple question, which is, has a certain country reached the life expectancy of United States by now? So if you look at India, India still hasn't reached the life expectancy of United States in 1952. The economy is growing fast, but it still hasn't reached the stage. If you look at countries like Singapore, Switzerland, and United Kingdom, they look very similar to United States. South Korea is a fascinating case, because South Korea starts off and develops during the 1950s, and the slope is very sharp. It's still kind of catching up to United States, but it starts off much kind of lower down. China doesn't see any gain in the 50s and 60s, but once it takes off, it has a phenomenal gain, right? But China, we think of China as a fast-growing economy, but what often people miss out is what matters is not just the growth. What matters is the accumulated growth. You could be growing fast, but the question is how long have you been going fast? How much growth have you accumulated? So even though China has been growing really fast, its accumulated growth is still quite low. And so its per capita income is still not, it hasn't caught up. It's still in the middle income countries. And its accumulated growth is relatively low. And its life expectancy is just above where US was in 1952. Botswana is a fascinating country. So Botswana is not the rule, it's more of an exception. And I must admit that if you ask me, I can't tell you for sure why the life expectancy has gone up and gone down. I suspect it is because of the AIDS crisis, but if somebody knows exactly why it is, please do correct me. Rwanda, Rwanda's explanation of why the life expectancy dropped suddenly is the genocide, presumably, right? So this gives you kind of an idea of how the life expectancy is moving. And the reason I put in this graph is to say, to a large extent, most countries follow this pattern, but Botswana is an example. So Botswana here, 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 and here. So Botswana is an example which bucks the trend. It is not, it doesn't follow the trend that other countries have been following. Now, increases in life expectancy is a great example where you create winners, but you don't create losers. So if you can push up life expectancy in your country, I mean, this is, you know, if your life expectancy goes up, your chances are there are no losers. And so it's kind of, it gives you tantalizingly, it kind of gives you an idea where growth may not be that important for the developed countries and the middle income countries, but growth, economic growth and per capita is absolutely critical for the poor countries. And again, let me give you kind of a preview into what we're going to talk about. Poor countries, their capacity to create public goods or a healthcare system or infrastructure is limited by the fact that they don't have any tax revenue. So most poor countries struggle because they don't have any tax revenues. Because they don't have any tax revenues, they don't have any public goods. Because they don't have any public goods, they don't have economic activity and they don't have tax revenue. You know, a great example of this is electricity. Electricity's impact on economic activity is phenomenal. Take away electricity, and you know, we've seen what happens in Texas. Take away electricity for 3 days, the whole society falls apart. If you look at the impact of electricity on small firms running out of, you know, kind of huts in India, you know, I've looked at papers that do that. The effect of electricity is phenomenal. But providing electricity requires a kind of a regulatory framework or requires production, which requires tax resources. And often the countries, you know, countries where the GDP is as low as Ethiopia or, you know, kind of countries where India and China were in 1950s, they are so, you know, they're so poor that they are not able to provide public goods. And because they're not able to provide public goods, they are not, the economic growth is relatively constrained. And so while it's very clear that with life expectancy, you can create winners and not likely to create losers, in a similar way, when you start creating public goods early on in your development process, you create lots of winners. You do create losers as well. And, you know, so don't get me wrong, because every time a road is built, it's built on a farmer's land. Every time an electricity plant is built, it's built on a farmer's land, and the farmers often, you know, depend on this land, and you know, they kind of, you know, it's never very pretty how the government snatches the land away from there. There is all developing countries have this problem. So, you know, I'm not trying to gloss over that fact, but you do create phenomenal amount of winners if you can provide some basic public goods. This is what the GDP per capita story looks like from 1952 to 2017 for 12 random countries. You know, so I've kind of picked up 12 random countries, and because facts are more scarce than anything now, I thought this graph would be very useful. You know, we've all, well, at least if you lived in UK, you've lived through the Brexit phase. And what was fascinating about the Brexit phase was that facts were very scarce. You know, arguments were about this country is going at this rate, and that country is growing at that rate, so we need to trade with them. We don't need to trade with them. Turns out growth rate matters very little accumulated growth rate is what matters. So if you look at accumulated growth rate, that's what's reflected here. How much growth rate have you accumulated? So it tells you some interesting things, which I'll again come back to this graph. So this is kind of motivational ideas, but by the end of the lecture, I would have explained some of the puzzles that you see here. So the first puzzle that you see here is Singapore has outperformed United States. United States outperforms or has outperformed for the last 100 years almost all countries in the world, right? It has outperformed almost all countries in the world, even though United States is far more unequal than some of the European countries. When it comes to actual growth rate, it has outperformed most countries in the world. But Singapore has outperformed United States. So you can see that United States starts off at this point and ends up here. And Singapore, even though it started much before it, it's outperformed. Does anybody want to speculate why? I mean, I don't think there is a conscious narrative that Singapore is outperforming United States. I mean, if you read the media, if you read the newspapers, you don't see that. And a couple of years ago, when I started looking at this graphs, I was surprised because I'd not expected that. By the way, this is not nominal GDP. This is real GDP. So this is GDP converted into goods. So, the prices have been taken into account. Any guesses why Singapore is outperforming United States?
Could it be the population in the US and in Singapore, and having the number of multinationals in Singapore is a lot more compared to in the US? For example, head offices of so many different multinational companies.
So the question is, do multinationals create prosperity, or do multinationals go where there is prosperity? Right. So that it's not clear the causation, which way the causation runs. Mm-hmm. Right. It could be that the multinationals are going to Singapore because it's prosperous. And if all you needed to do was get multinationals to develop, the question is, why can't we do that in the United Kingdom? Right. Well, I mean, we could get, London is the financial center of the world. What does Singapore have that United Kingdom doesn't have? I don't have United Kingdom, but United Kingdom has underperformed. Yeah.
Just from my own research, what I've seen in Singapore, the level of taxation breaks and readily availability of the reduction of bureaucracy is a lot better environment in Singapore than in US. In the US, obviously, you have to go through so many red tapes to get your multinationals.
So US is outperforming the rest of the world, right? So by that logic, US should not be outperforming the rest of the world, right?
Yeah.
Right. So so here's the thing. I'm trying to get to more fundamental factors, right? Okay. I mean, in the sense that when it comes to developed countries, institutions, they learn from each other. Institutions evolve. If one country is doing something, another country tries to copy that, right? So, Silicon Valley was a success in the United States. Gordon Brown in late 90s created an initiative to create the silicon fen, and 20 years down the line we're seeing the benefits of the silicon fen. The kind of a bit of a cluster around Oxford and Cambridge, where there's a lot of innovations going on, right? So countries constantly try to copy, and we want to think about fundamental factors that stop them or encourage them, right? What is structurally different about Singapore? I know.
So-
By the way, I'm not pretending to answer this. I just want to push you further to think about it. I don't have an answer for this, so I don't have a clear answer for this. But Singapore has structurally something very different.
Was it more research and development and more innovations going on there compared to rest of the countries? Just following up from what you just said.
Not Singapore lags behind in research. I mean, I'm just pulling stuff out of my, kind of knowledge base head. So, you correct me if I'm wrong about this, but when it comes to innovation, Singapore is not the hub, right? I mean, a public, innovation is often comes out of public universities and then gets commercialized. Singapore is, for commercial, it's great. But when it comes to actually producing fundamental innovation, I'm not sure it has the right structure. No, I'm not sure the output is there.
Could a structural difference be the like just quite basic, but the geographic location? So like Singapore, kind of like as around it is like kind of like the other countries aren't as like sound institutionally and aren't as developed maybe, or like they are getting there, but as like it's kind of like a hub for finance because of its like it's kind of like got a good standard of practice there maybe.
Can I leave this as a curiosity? I mean, so I've done my job. I've kind of created a question, and can I leave this behind as a curiosity? And we're going to do some growth models next week, and then we'll do some public goods the week after, and we'll come back to this. But please do think about this. Look at this graph and do think about, why is Singapore outperforming United States, and why is United States outperforming the other countries in the world? Okay. So, if you find out something fantastic about Singapore, I have a conjecture, but I don't want to put this conjecture because I think it's a bit, I don't want to say my conjecture is better than yours. I want to leave this out as an open question, and let's have a discussion towards the end of the lecture and see whether we can use the framework. Okay, so let me put it this in a kind of more eloquent way. What the course is going to do is going to give you tools to pick up candidates, right? So we picked up some candidates why Singapore might be doing better. So, the person earlier was saying it is about bureaucracy, it's about research. Dominic said it was about the countries and institutions surrounding it. So what we're going to do over the next few weeks is going to give us a list of candidates that we can pick. And this is a time at which I should tell you the way I think about these things, or at least my intellectual framework. So the way I think about these things is there are two ways in which you can answer a question. So imagine, and indulge me, I'm going to take a couple of minutes to tell you, build this example. So imagine you go to a strange city and you're supposed to cross a road. You know nothing about the city. The question is, how will you cross the road? How will you make the decision of crossing the road and ensuring that you're safe? What tools would you use? This is a basic question, because when we make decisions, what kind of tools do we use, right? So if you want to understand whether United States is outperforming the rest of the world, or why is it outperforming, or Singapore, we're going to use some tools. Much easier to think about these tools in terms of crossing a road. What tools do you use?
So observing others would be the first, because you can assume that other people are crossing the road. So you'd observe those people to follow the cultural norms in that city that you're in.
Let's make it slightly more difficult and say lots of traffic, no other people on the street. right? And in a sense,
Yeah.
you're absolutely right. One way to do this is to just copy what everyone else is doing, but then you're not making a decision, right? So I'm trying to push you to make a decision.
So assuming that I have to cross the road, there's no sort of alternative to do something else. I think it'd have to be a measurement. It would be an observation of traffic. What's it doing? Is there a certain, does it go fast or slow at different points, and finding a observation before making a decision.
Okay, so you'll make your decision empirically, right? Empirically, you'll collect empirical data and make a decision empirically. Anybody else? Is there another option? Well, you could also make your decision logically, right? If you don't have an R to observe the road, you could also make a decision logically to say, I'm going to look left, I'm going to look right, then I'm going to look left again, and I'm going to look right. And when I can't see anything, I'll cross. Right? And so we are always in this world where we can make decisions either empirically or logically. Sometimes logic is better because you don't have to waste collecting data. And when you collect data, you collect imperfect data, and that data takes a long time to process, and you don't even know whether it is good data or not, right? So, if you try to start collecting data on cost benefit of a road, chances are you'll never be able to get good quality data. You could use logic to make that decision. And other times, when you make logical decisions, if you don't take your logic and test it vis-a-vis the empirics, you could continue to make the wrong decision and never get corrected, right? And in answering this question of United States versus Singapore, we were hitting on the same situation. Should we do this logically or should we do this empirically, right? And what I'm going to take you through the course is a little bit of empirics, but a lot of logic. And once we finish the course, I would hope that you have a logical structure that you can use to arrange the world and collect data. And what I mean by that is there are channels through which phenomena are connected. What logic often allows you to do is think through those channels. And once you find a channel, you can logically find another channel. And then often you want to test whether that channel works empirically or not, right? So the relationship between logic and empiric is quite convoluted and indirect. And if this debate is old. It goes back to Plato versus Socrates, actually, whether you should think logically or empirically. And by the time we finish the course, I would have hopefully got across the logical structure that I have in my mind, which should be a starting point for all of you. And then we can come back and say, can we look for candidates? Does the logical structure help us look for candidates? And actually, in reality, what often works is that if you have a logical structure in your head, you know where to look for data. If you don't have a logical structure in your head, then you start looking for data, and often, you may miss the data you should be looking for. Okay, I should move on because I can gab on and on about this. Right. Now, what I want to talk about next is this paper by Dasgupta and Veal, which kind of takes this idea of living standards and life expectancy and makes it more concrete. So what they do is they took 6 measures: political rights, civil rights, infant mortality, life expectancy, per capita income, which is the 6th one. Sorry, there are only 5. So they did these 5 indicators, and what they wanted to look at was how these indicators are correlated with each other. Now, what they were trying to do is trying to understand whether, kind of depending on life expectancy or infant mortality. So, okay, so GDP per capita, average income, is not a good description for living standards. It's not a great description. I mean, that's not how we as humans experience life. We experience life on our living conditions, and infant mortality and political rights and civil rights are a much better indication or description of how our lives are spent, right? But turns out the problem with these parameters are that if you want to make a road, if you want to construct a road, or you want to start an agricultural program, if you want to evaluate its impact on life expectancy, you would never get a decision, because you'd have to wait for 30, 40, 50 years to get an understanding of how this is going to have an impact on life expectancy, or how this is going to have an impact on infant mortality. So the problem that we have is infant mortality and life expectancy are great indicators, much closer to describing the living standards in poor countries. But the problem they have is that they're not very practical. The advantage of average income GDP per capita is that you have lots of data, even in relatively poor countries. They collect a lot of data, and collecting data has become much easier as time has gone on and it's got standardized. So it's much easier to understand how the road would impact GDP per capita in the next 5 years. But it's more difficult to understand what impact it would have on infant mortality and life expectancy, right? So on one hand, life expectancy and infant mortality are a much better description of what living standard or a human condition is, but it's not very practical for policy making. Whereas per capita income is very practical for policy making. But the question is, does it actually tell you something? So what Dasgupta and Wheel do is they use something called the Bardo ranking system. And basically, I mean, I've got the reference, you can look at the paper, but basically what it does is it ranks all the countries on these 5 parameters. So in life expectancy, which country has the highest rank, the second rank, the third rank? Per capita income, which country has the highest rank, the second rank, and third rank? And then what they look for is the correlation between the ranks. And this is what they find. So this is the correlation table in their paper. So turns out life expectancy and per capita income are highly correlated. Life expectancy, and infant mortality are highly correlated. I think I may have messed up the table a little bit because life expectancy should be perfectly correlated with life expectancy. I think okay, so I'm gonna redo the table. I think I've got the numbers slightly wrong here. But if you look at the correlation matrix, the thing that comes across from that correlation, so I'm going to update this slide after the lecture, and I'll correct the numbers. But basically what emerges out of that is that life expectancy is one factor which is highly correlated with all other factors: civil rights, political rights, infant mortality, and literacy rate. But GDP per capita is not bad. It's not as high of life as life expectancy, but GDP per capita is relatively close to life expectancy. And so GDP per capita is capturing the impact it's having on all the other things, right? And so that gives us a little bit of a kind of idea why GDP per capita, focusing on GDP per capita from a practical perspective may not be that bad, right? And we've already seen that small increases in GDP per capita is highly correlated with large increases in life expectancy, right? This is just a more detail. So that graph, I mean, I looked at that data only because I kind of got inspired by this paper. This paper has become the basis of human development indicators. So there's a body of work in the 90s that developed ideas, and then slowly people started moving towards human development indicators. And this was one of those early papers. And by the way, I mean, this is just a side thing, but Dasgupta, he was one of my mentors at Cambridge. Absolutely fascinating character. And when it comes to his work on environmental economics, he has done some really interesting work. One of the things he's done is recently, he has done a report for the Treasury. It's come out about 2 or 3 weeks ago. It's called the Dasgupta Report on Environmental. It's a 600-page report, absolutely fascinating, and it is absolutely a magisterial work. So if you want to learn about environmental economics, you don't have to go anything further than that report. And the thing about Professor Dasgupta is that he writes beautifully. I mean, he writes like he writes beautifully. It's really fascinating to read him as well. Okay. This was just a prelude to get you to the production function, the idea of a production function. So economists love the idea of a production function. It kind of underpins a lot of the work that's done on the supply side of the economy. So the idea is a production function just maps out inputs into outputs. It's best understood at the firm level. So think of a production function for a coffee shop. So for a coffee shop, the production function looks as follows. A coffee shop has building, it has cutlery, it has coffee machines. So it's got a stock of all these physical things. And the word stock is really important here because it's a stock of things. It's just there at the point in time. And then it has animate, kind of inputs, which are humans, right? So humans with different skills, they are the other set of inputs. So you would have waiters, you would have baristas, you would have manager, you would have cleaners, right? So there's the other range of inputs. Now, these two range of inputs are not enough. You also need ideas. Why do you need idea? You need a plan to bring the capital and the labor together. So all the human labor and all the physical capital has to be brought together in a plan. And that plan is absolutely crucial in ensuring that the inputs get converted into the output, right? So I've only mentioned capital and labor here. We'll pick up on the ideas bit in the next lecture. But basically, a production function is a bunch of inputs come together with an idea and become output. So in a coffee shop, what's the output? Well, it's coffee, but it's also the atmosphere in which the coffee is served, right? So it's not just coffee. A coffee is an output for a dispenser, coffee dispenser. A coffee shop often also sells an atmosphere. You sit on the couch, you can do your work there, there's music playing. So the output is coffee plus the atmosphere. The inputs are a bunch of physical things and a bunch of humans coming together with a specific set of ideas. It also requires raw materials. So you need coffee, you need sugar and milk, but those are not inputs. They are kind of raw materials, okay? Now, understanding what a production function looks like at a firm level is intuitive, but understanding what a production function for the economy looks like is more difficult. And what we want to do is take a production function, the idea of a production function, at the level of the firm and try to find a way of trying to get to the economy's production function. And why do we want to get into the economy's production function? Because we want to get to the economy's production function to understand how the output can be increased. If you don't know the production function of the economy, right, it will be difficult. Now, the problem is that production function at the level of a firm is very clearly defined. But the question is, how do we aggregate it all together? You know, a coffee shop is producing coffee, a supermarket's producing services for their customers, hairdressers are producing haircuts. How do we aggregate them all together? The question is, can we? Is there some way in which you can aggregate them together and find the production function for the economy? If we can't find a production function for the economy, it's very difficult to say anything about how do you encourage economic growth. So what helps is this idea of returns to scale. So the idea of returns to scale is ask yourself something simple. What if I take a particular coffee shop and I double all the inputs, right? So all the inputs that I've described, I double them. I double all the kind of physical inanimate objects and I double all the animate objects. The question is, would the output double, more than double, or less than double? If the output exactly doubles, that means you have constant returns to scale. That's just a mouthful, but it's just a definition. So the constant returns to scale is that if you double the inputs, the output will double. If you double the inputs, but the output more than doubles, you have increasing returns to scale. That often is true when you're starting from a very small scale. So when you start from a very small scale, you start making some cake at home. If you just make a small cake, you'd find that if you double your inputs, you would actually be able to make a kind of a more than double the amount of cakes, because you kind of, as you scale up, you're able to buy things in a cheaper way. You're able to do them in a more effective way. On the other hand, you could also have decreasing returns to scale. And the idea of decreasing returns to scale is that when you have decreasing returns to scale, as you double or multiply the inputs by any proportion, the output less than doubles, or the output doesn't react in the same proportion. So constant returns to scale, increasing returns to scale, and decreasing returns to scale, right? These are the kind of, this is kind of a fairly, these are kind of fairly critical definitions for any study that wants to look at this thing. So if the definition is clear, I want to build up this idea into how we can use this to build an economy's production function. Any questions about this or anything else we've covered till now? Is there anything I can clarify? There's something in the chat. Okay, so the idea is that we should expect, and in here we're trying to use logic. So we are in the world, we're using logic, we're not using empirics, we're using logic. So if a firm has increasing returns to scale, which means it's going to increase in inputs, and the output is more than double, there's no reason why it should not scale up. Whereas a firm which has decreasing returns to scale, it should be reducing its scale. And so the idea here is most firms in the economy either increase their scale or decrease their scale and get to somewhere in the middle where they have constant returns to scale, right? Now, whether it's empirically true or not, that's an interesting question. But logically speaking, that's where we should be approaching, right? There is no reason. The logic is that if you have increasing returns to scale, that means you have incentive to scale up. If you have decreasing returns to scale, you have incentive to scale down. When you have constant returns to scale, scaling up or down doesn't make a difference. So that scale, you want to get to that area in the middle where you have constant returns to scale. So now, if you have constant returns to scale, one of the interesting things about constant returns to scale is that the size of the firm doesn't matter. So if you were producing wheat in a farm and you had constant returns to scale, what would it look like? That means that if you have 100 people working on a piece of land, if you divide up the piece of land into exactly 100 pieces and give each person a piece of land, the output of the total field should not change. So the idea of a constant returns to scale is that scale is not important. You can divide up or you can aggregate up. It doesn't matter. The scale is not important. And this is the critical thing that allows us to aggregate the production function. Why? Because if scale is not important, if firms in the economy tend to move towards constant returns to scale, then we can scale up because the scale is no longer important. What matters is what the aggregate output is. So if you take a country with constant returns to scale, and all the firms in it have constant returns to scale, then whether the country works as a whole or it gets divided up in hundreds of firms or thousands and thousands of firms, it doesn't matter. Now, this is obviously a simplifying assumption, right? There are reasons why this wouldn't hold true, and that's not very difficult to do. But what it does is it allows us to conceptualize the economy in a way so that we can work out some things, right? So we're making this assumption very clearly aware that it's not a perfect reflection of reality, but the deviation of the reality that if you're conscious about it, we will get an insight from it, which would be very useful, okay? So one advantage of having a constant returns to scale production function is, and I'm going to do a little bit of mathematics here, it's not too complicated, is that if the production function looks like this, then what I can do is, so my production function is YFKL. I want to scale up and multiply my inputs by lambda, right? So we said lambda was equal to 2. Let's take an arbitrary number lambda. What I want to do is multiply my inputs by lambda. So if my production function, I multiply my inputs by lambda, my output should also be multiplied by lambda. Just think of a situation where lambda is equal to 2. So that means if I double my labor and double my capital, my output would also double, right? Okay. Now, if this should hold true for all lambdas, so I can just put lambda equal to 1 by L. What is L1 by L? The total labor force of the economy. I have just divided the total labor force of the 1 by the total labor force of the economy. I've set the lambda. So if constant returns to scale holds, then it should hold for all lambdas, including this particular lambda. So let's put this back in. So that would mean, if you put this back into the equation, that means it would be Y over L equals F K over L 1. That means I can write this as another function where Y over L is a function of K over L. What is K over L? That simply is the capital labor ratio. So that's the value of the capital divided by labor, right? And that's a bit of an intuitive idea. The more capital a labor has, that means the more computers you have, the more machines you have, the more you can use those machines to work. So on one side, you have capital labor. And the other side, Y over L, it's something that we saw earlier. That's just GDP per worker. Why? Because this is the output labor ratio. Okay. Now this particular expression is really powerful. And the reason it's very powerful is because it takes the whole complicated economy and makes it really simple. All you have to visualize is a one worker production function. What is a one worker production function? In a production function, on the right hand side, if you have one worker and she has certain amount of capital, the question is, how much would she produce in terms of output? So now what you have to do is to understand the production process of the economy. All you have to think, it's a very parsimonious kind of expression. All you have to think is, how much capital does the average person have? That is going to give a relationship in terms of how much output an average worker will produce. So on the right hand side, this here represents average capital, the average amount of capital each worker has in the economy. And this here gives you the average amount of output they produce. So now, if you want to do this for the coffee shop, what you have to do is you have to think, reduce the coffee shop to one worker coffee shop. And the idea is, if you give that one worker more and more capital, what is the rate at which their output would increase? Now, I can see, I mean, I'm sure all of you have a lot of doubts about this if you haven't come across this before. And all your doubts are absolutely valid. But the huge advantage is it allows us to describe the world in a very simple way and allows us to find policies, because it basically says, I have now a relationship between the average capital that I'll give a worker and the average output. So if I want to drive the GDP per worker in the economy, I have to think about capital accumulation. The more capital accumulate. And next week, what you're going to do is we're going to talk about the capital accumulation process, exactly how the capital accumulation process takes place. But for now, this gives us a really nice and simple relationship where it basically says output per worker is determined by capital per worker. Now, what I want to do next is I want to see exactly how the output per worker and capital per worker has evolved for various economies around the world in the last 50 years, right? So I want to actually see numbers, and I want to see whether we can see some kind of a pattern or not. Now, one thing we can logically predict is that at the margin, the more capital, so when you start getting capital, it makes you more productive. But at the margin, the more capital you get, the less productive that capital is at the margin. If you think of a Robinson Crusoe economy, you're Robinson Crusoe, you're stuck on an island, you don't have any tools. If somebody gave you a knife, you would become really productive. But if somebody gave you 5 knives, the 5th knife is almost useless. If you're a computer programmer and you have a rusty old laptop, if somebody improves your laptop, that increases your productivity significantly. If somebody gives you 5 laptops, the 5th laptop is basically useless, right? So what it should tell us is that as capital accumulation takes place, in the beginning, it should lead to really high increases of in terms of productivity. But over a period of time, it should go down, right? That's what it should be. Now, let me stop for a second here. Any questions about this? On the Moodle side, there is an office hour Wednesday, 12 to 1. So, I'm very happy to have an informal chat if you want to come to the office hour, or, if you can't make the office hour, you want to kind of drop me a line. We'll always be able to find a time. Right. So now let's look at the number. If we were to map out capital per worker and output per worker. So on the horizontal axis, we have capital per worker. On the vertical axis, we have output per worker, right? And this is how the economies evolved from 1952 to 2012. Now, let's try to fit an average production function through it. And so if you want to put an average production function through it, right, with diminishing margin of capital. So, as you accumulate more capital per worker, the output per worker starts decreasing. That's what it should look like. So the fascinating thing is that from 1955 to 1994, it has a specific pattern that our logic should have predicted. But from 1994 onwards, it starts defying the logic. Right? And this is where kind of interesting, because you take logic, you make a prediction, then you go to the data. Now, turns out, when we build on this next week, both are important. The first part is telling you that for some period, United Kingdom had diminishing marginal productive capital. That means basically capital, as you accumulate it further and further, its impact was diminishing. But that pattern suddenly stops in kind of 1995-94. Now, what I've also done is calculated. So this line, this particular line, so if you take any particular point, this distance here is the output per worker. This distance here is capital per worker. And this distance here, this is the angle of the line, is output per worker divided by capital per worker, which means it is output capital ratio. How much output are you producing per unit of capital? Now, it turns out if you have a diminishing marginal capital, a production function that diminishes, then over a period of time, this line should shift down. So, it should come down. That would the logical production assumption be from diminishing marginal productive capital. Turns out UK was following that for some time, but in 1994 it starts defying it, and that's an interesting story. Somebody won a Nobel Prize for explaining this. Somebody called Paul Romer won a Nobel Prize 2 years ago. In the 1980s, he came up with something called endogenous growth theory, and he was able to explain why countries like United Kingdom did not have diminishing marginal productive capital. Turns out, if you were to compare the capital output ratio, is 1.93 in 1994. But if you compare it to the last page, it was 2.55. So the capital output ratio is also going down as the line is becoming flatter in the early period. Let's look at what has happened to France. So it turns out France doesn't see the break in trend that United Kingdom has. So when it comes to France, France has a bit of a dip in the 80s. So in the 80s, something goes wrong, but then it goes back and catches up to its previous trend. Okay, and again, if we compare the marginal product of, sorry, the output capital ratio. By the way, the output capital ratio is a bit of a mouthful. Please do think about it, because next week what we do would critically depend output capital ratio. So the output capital ratio is a good measure. It's kind of visually easy way to tell whether the capital at the margin is becoming less productive or not, right? And the logic there is that if capital starts becoming less productive, then the benefits that you can get out of capital accumulation are limited. So once you become a developed country, you can accumulate as much capital as you want. It's not going to make any difference. You will not get any growth out of it. If you're a poor country, accumulating capital is going to benefit you, But over a period of time, once you've accumulated enough capital, the extra capital is just going to be waste, right? And if that is true, then the output capital ratio should be decreasing. In United Kingdom, the output capital ratio did not decrease. It actually started increasing after 1994. So that's the puzzle. I'm just giving you some facts here. We'll come back and revisit this. I'm obsessing a bit about output capital ratio. Next week, I'll explain to you why this is absolutely critical, right? So it may not be obvious right now. Okay, I'm not going to do anything new. I'm just going to show you some more graphs. What does China look like? China is fascinating. So China's output capital ratio is 14.35 in 2009. Remember, UK's output capital ratio was 2 point something. So China's output capital ratio is 7 times. But even China sees a decrease in output capital ratio. So from 14 in 2008, it's gone down to 12 in 2015. So China has the same thing, is experiencing a decrease in the slope of the line, which is reflective of the fact that at the margin, the capital they're accumulating is becoming less and less productive, right? So remember, United Kingdom bucks the trend, something different starts happening, and that's the puzzle. But China seems to be converging towards kind of, kind of a point where the marginal productive capital is decreasing. This is what United States look like. So in case of United States, again, it's following a trend. It looks like a neatly produced production function. And there's nothing surprising about it. Next week, I'll show you what happened to United States before 1950s. And the story is entirely different. So 1950s onwards, United States production function is a very predictable, well-behaved production function. But before that, something dramatic happened. So I'll show you the next one. What's useful to note is that United States output capital ratio, so output per unit of capital, is 17.64, quite close to China, but much, much higher than UK and France. So in terms of growth rates, this is what the kind of pattern looks like. China and India are experiencing phenomenal growth, but that's because they're starting from a very low capital base. And so the capital is very productive and it's fueling the growth. Why and how, that's kind of we'll get into the mechanics of this next week. But once you've accumulated sufficient amount of capital, the growth that you can get out of accumulating capital is more limited. And so the puzzle is, why do developing countries grow at all? Why do developed countries grow at all? Why does United Kingdom grow? Why does US grow? Because that growth could not be coming out of capital accumulation, right? Now, this is just a kind of a teaser for next week. I'm hoping that I can answer or kind of provide a framework where the questions I've created this week get the answer. But what you should take away from this is more in terms of look at the facts. Once I post the lecture notes, read the lecture notes. The lecture notes are fairly are absolutely, they're not very different from my lecture. There are some things in greater detail. It will allow you to kind of, if you miss some bits here and there, it will allow you to step back and think a little bit. There are some examples here and there, but what you want to take away from this simply is that we live in a world where there is a growth puzzle. One growth puzzle is, why is Ethiopia not growing? What is India and China doing that Ethiopia is not doing? That's the first growth puzzle. The second growth puzzle is, if India and China are growing because of capital accumulation, then why is United States and Singapore growing? Because they have very high levels of capital per worker. The question is, why are they growing? And these are the two questions we want to answer. We'll answer them with a simple growth theory question model next week. And then once we've done that, I will kind of get to the more interesting part of the course, where the missing link, the answers have often incorporated the private sector, but it was not fashionable for economists to sing the virtues of government in the 90s and 2000, early 2000, at the point at which growth theory was developed. Increasingly now, the role of the government is kind of coming in, and the literature is getting really interesting in terms of dealing with public goods. Do public goods matter? Your capacity to develop public goods matter. So in a way, I mean, and I'm just going to stop in a second, just one more minute, but and then if you have any questions or comments, we can talk about that. So this capital that we've been talking about, capital per worker, right? I've talked a lot about it. This is private capital per worker, right? So in a coffee shop, the capital was privately owned. The coffee shop was privately owned. The machines were privately owned. The tables were privately owned. But as I kind of hinted earlier, the productivity depends a lot on electricity. And electricity is often not privately owned. It's often publicly owned in developing countries. Roads are publicly owned. So the question is, how do we take this framework where everyone's been talking about private capital? How do we add public capital into this, right? So next week, I'll tell you about complete the story with the private capital and make an opening so that we can bring in public capital. And once we bring in public capital, infrastructure is just a subset of that. And it's a very critical subset, but it's just a subset. So week 3, week 4, and week 5, we'll start developing ideas of how to bring in infrastructure. And I can almost assure you that you'd be surprised at how these things are linked. So the world of infrastructure is relatively boring, I think. Everyone thinks that we know what infrastructure is. And I'm hoping to kind of provoke you to think and redefine infrastructure. In a world where physical location doesn't matter, in a world where actually our internet location matters very much more than our physical location, the question is, why do roads matter? Right? I mean, in the world of internet, why is it that the cities where the physical infrastructure is better are still outperforming the rural areas? With the internet, the world should have become a flatter place. Urbanization should have been reversed, but that's not happening. So I'm hoping that this is kind of this course is part of a book project that I'm developing, and I'm hoping not just to kind of give you some interesting answers, but I'm also hoping to kind of get some interesting feedback on what you think about the course in terms of, did it answer the questions you had? Or I'm sure a lot of you have interesting experiences. So I'm also interested in kind of at the end of the course, trying to get to grips with what your experiences are. Does it match with what we're watching? Or do you have some ideas about how to push this research agenda further? Okay, I'm going to stop there. 8 minutes. Now it's entirely up to you. I'm going to stop talking. If anybody has questions or comments, it doesn't have to be just questions. It has to be comments, and you don't have to talk to me, even if you want to, you generally mull over things and talk to each other. I'm happy to do that.
Hi, I've got a very good. Apologies, I got in very late because I got mixed up with my timetable. If the course was starting at 11 o'clock, I just wanted to know how the assessment is going to be worked out for this course.
So you write a term paper, 1,000 words.
Okay.
And the instructions on the term paper would be very clear. I I will put up the term paper at the beginning of the 3rd week.
Okay.
And it would have very clear marking criteria. The marking criteria that I work on is 20% presentation, which is, can you write an essay? Can you write an essay? If you write bullet points, that's not a good idea. Can you write a decent introduction? Can you write a decent conclusion? 50% knowledge of the material taught in the course, 30% your ability to effectively argue. So, do you understand the definitions? Do you do you understand the definitions? Can you fully explain it? Can you communicate the definitions? Right. And 30%, your idea of, can you turn that into an effective argument? The one thing that I really don't like is people citing references they haven't read. So when you write your term paper, you are not required to cite any references. But if you cite any references, you should have read it. If you cite a reference and you haven't read it, you've just read the abstract. And so people get in this habit of citing for the sake of citing. I'm going to track down the reference. I'm going to read that reference. And if I find that you haven't read the reference, I'm going to penalize you. And the reason I like doing that is because I think we should read very little, but read very carefully. So for this course, you'd have to read very little, but read very carefully. You don't have to go and look for references. But if you look for references, you find references, that's absolutely fine. The second thing is that really helps is because it means that only people who've done the course can write an essay. So we have a problem where some students, a very small minority of students, get professional writers to write essays, and they turn out generic essays. And the way I structured the term paper, it becomes very easy for me to spot if somebody who hasn't done the course or is vaguely familiar with the course has written the essay. And so then that means you just go up against a board and you'll have to defend your essay, right? So I'm sorry to sound a negative note, but we've had lots and lots of problems of students buying essays. So for my course, I'm sure you're not thinking about this, but it would not be a good idea. That's my marking criteria. But everything would be crystal clear in the term paper assessment that I'll give you 2 weeks from now.
Okay. Do you know when the assessment is due? Is it soon after the
26th April.
26th of April. Thank you very much. I just had one more question.
Yeah, sure. Yeah.
I just wanted to know if there's any specific infrastructure development economics books that you would recommend us to read just to get a bit more understanding along with this course.
The thing is, there isn't a book. And the lecture notes that I'm writing, I started writing those lecture notes because I had no option. There are no books.
Okay.
There are some books that deal with growth theory, but they don't mention infrastructure. All the books that do development, I can give you references for development books. They don't mention infrastructure.
Okay.
So infrastructure is only mentioned in the finance world.
Yeah.
In the finance world, they make assumptions about perfect markets and they do cost benefit analysis. And, if you'd come in the beginning of the course, so, you can read the recording, I've spent some time talking about why the cost benefit analysis is very problematic when it comes to infrastructure. So infrastructure world assumes market work and then use the markets to value things and do cost benefit analysis. But the whole problem with development is, as we will see, that markets don't work.
Yeah.
So it's a course which doesn't have a textbook because there isn't a textbook, unfortunately.
Okay, thank you. Thanks a lot. Appreciate it.
There is, the last thing I would say is I have a paper from 2008, which I'll talk about. As far as I know, that's the first paper that starts looking at infrastructure and growth theory. It's a working paper. I think it's relatively easy to read if you know a little bit of economics, but that's, as far as I know, there isn't. If somebody finds any references which specifically deals with development infrastructure, I would love to know.
Okay. Are you going to? Well, I assume all your lecture slides are from what your paper in the background is. What you're doing at the moment.
No, so the paper deals with a very specific area.
Okay.
The course is much wider than that.
Okay. Cool.
So the paper is only part of it, but it's more like I wrote this paper. They gave me this course. I started looking at the course. When you write a paper, you think with a narrow perspective. When you start doing a course and you want to teach, you want to look at everything. And I realized that there are large areas that I hadn't even thought of when I wrote that paper.
Yeah. Okay. Thanks for sharing that.
Sure.
Thank
you. Anyone else? You could also tell me whether you found the lecture difficult. So ZU just said that it seems the link to Aniket 2020, the economic development story in the reading list cannot be opened. I'm going to sort out that link. I was updating it. That's why I took it offline. I'm going to sort it out. And in the next hour or so, you'll be able to use that link. Right. Any more questions?
Question. If in our term paper we want to cite what's been mentioned in our slides, in our PowerPoint, how should we cite those information on our slides? We should go back to the books.
Sorry, can you put that? Can you put that again?
How should we cite if we want to talk about something mentioned in our slides on our
lecture slides?
Yeah, how should we cite those information on our slides?
I mean,
we don't need to cite.
It's between me and you, so you don't have to cite. If anything in the lecture material is there, you don't have to cite it.
Okay.
I mean, in the sense, I know it's there. You know it's there, right? You don't have to cite it. You only have to cite something which you bring from outside.
Okay.
Okay. Wikipedia, don't read it. Read it as a starting point, but okay. So this, I think, is a bit helpful. I mean, I think this is a bit helpful. What often happens is somebody reads something in the reading list, and then instead of trying to read it from the reading list, they Google it, they find Investopedia, they find Wikipedia, and they're trying to get the understand it through that. Turns out you often end up getting more confused because we are not teaching basic stuff. The question, this is a postgraduate course, so we're talking about concepts which are fairly involved. Wikipedia would write something, Investopedia would write something. They may not be writing it very clearly, and it's going to get you very confused, right? So when you start looking for references, the first thing you'd have to do is to do it systematically. You need to go to Google Scholar. You need to look at the citation score. So I don't expect you to go and look for anything because the reading list is fairly comprehensive. If you're able to finish the reading list and you're looking to read more, then that's absolutely fantastic. But if you go and cite something without reading the reading list, chances are you're going to mess up. Is that clear? Is that clear? I mean, in the last marking round, and then I'll give you a particular example. There is an example about there's a particular paper in 1950s on why markets are Pareto efficient. It was written by Arrow, and it is a 1952 paper. He won a Nobel Prize for it. I was correcting an essay where somebody wrote and attributed that result to a 2014 paper in some random journal. Now, there is a result by Arrow. That 2014 paper was quoting Arrow, citing Arrow, but this person quoted that. Now, that's an example of not doing it right? Where you're taking Arrow's result and you're citing somebody else. Now, this is where, when you start going and looking for journal articles on your own, you have to be very careful. You have to be very skilled at finding out what the good journals are, how well it is cited, and that's a problematic thing. This is why my suggestion to you would be that if you want to read more readings, send me an email. Tell me that you finish your reading list. Send me more emails. I'll send you more references. I think that would be much, much better than looking for references randomly by Googling things. Having said that, I'm not stopping you from doing that. Does that make sense?
Yeah, thank you so much.
Okay.
Thank you.
I mean, this is basically the idea here is take a small amount and read it very carefully. Don't try to read too much and skim through it. Take a small amount and read it very carefully, and your term paper would be excellent. The link to Aniket 2020, the economic development story, I will update that. By the way, which is a ZU? Which reading list are you looking at? Because I think you're looking at a.
I was reading the one showing in the module overview. Like
Okay.
it is showing the course outline, reading list, assessment brief, and course calendar.
Okay, so the reading list, I have a link for reading list, and it's a web page. Is that the one you're looking for? That's the most updated reading list. I'm gonna, if there are references to the old reading list, I will remove that. But the most updated reading list is the web page. So that's the best one to look for. Okay. Anything else? Okay, it was lovely to see all of you. And, if you have any questions, drop me a line. Wednesday's office hour. Otherwise, I'll see all of you next week. Bye.
Thanks very much. See you next week.
Thank you. Bye.
Thank you.